This video is going to show you how to find the determinant of a 3 by 3 matrix by hand. It will involve finding the determinant of 3 separate 2 by 2 matrices, which you should already know how to do. Before we jump in with an example, let's just look at this formula up at the top left. Here we have a 3 by 3 matrix, and it's telling us how we should find the determinant. Notice everything's going to be based off this top row. We have our A, B, B, C, C. I also want you to notice the signs. We have a positive A, a negative B, and a positive C. So we're always going to be subtracting this middle part and adding this last part. The other thing I want you to notice is the letters that are in each of these 2 by 2 matrices that are multiplied by A, B, and C. Remember, scalar multiplication. Notice this E, F, G, H is what's left if you cross out your top row and cross out your first row. So when you're using an A out front, you're crossing off the top row and you're crossing off the column that contains an A. Get rid of some of this. Now notice the B, where the B is being multiplied, we have D, F, G, I. This comes from crossing out again that top row and now crossing out the column that contains the B. And we're left with D, F, G, I. And let's now look at the last one. I bet you can start to predict what this is going to be. We have the C, so again we cross out the top row, obviously, the one that contains the C, and then we cross out the column that contains the C, and we're left with D, E, G, H, which is exactly what's left over here. So I highly recommend as you go through these to actually write out this left-hand part each time, and then you're left with 3 fairly simple calculations. Now let's apply this all as an example. Here we have a matrix A. We want to find the determinant. Now remember, we're going to use this top row as those coefficients or those scalar multipliers on the 3 2 by 2 matrices. So I'm actually going to write those out first. So I'm going to have 0 times something, and then remember my next one's a negative, so -1 times something. And then I'm going to have plus 5 times something. 0, 1, and 5. Then I'm going to get the determinants of some 2 by 2 matrices. So the first one comes from, remember, crossing out the top row, crossing out the first column because we're using the 0. So I have 0, 5, 1, 5. The next one, I'm again crossing out the top row, because the 1's in there, and then I'm going to cross out the second column. So -1, 5, 1, 5. All right. And the last one, cross out the top row and last column, I have -1, 0, 1, 1. And now I just need to calculate each of these individually. Well, let's look at the first one. 0 times anything, well, that's going to go away. That's going to be 0. So we're going to be left with -1 times, well, you know how to find the determinant. -1 times 5, that's -5, minus 1 times 5, 5, plus 5 times -1 times positive 1's -1 minus 0. Let's calculate this out. -1 times -10, well, that's positive 10, plus 5 times -1, -5. That equals positive 5. So the determinant here is a positive 5. Let's look at another example. Now we're finding the determinant of this matrix over on the left. Remember, I'm going to start by writing out the first row. So I have 4 times, and that's going to be multiplied by the determinant of some 2 by 2, minus a -1. That's going to turn into a positive 1, because minus a negative, positive. So remember, this was a negative. Times some 2 by 2, and then plus 2 times some 2 by 2. Change my color and make this a little bit more clear now. So with the 4, you cross out the top, cross out the first column, -1, 0, -3, 4. We're really crossing out the row and column that contain this number that is in the front, that scalar multiplier. So the second one, we cross out the top, cross out the second column, and we have 6, 0, 1, 4. And now in the last one, we cross out that top row, cross out the last column, because that contains the 2, and we have 6, negative 1, 1, negative 3. Now we're not as lucky this time, none of these have a 0, so we actually have to calculate them all out. So I have 4 times parentheses, negative 4 minus 0, plus 1, parentheses, 6 times 4, 24, minus 0, plus 2, parentheses, negative 18, minus a negative 1, so it'll become plus 1. And we just go through and calculate this out, so negative 16 plus 24 plus 2 times a negative, that's a negative 17, so plus negative 34. So that equals negative 26. So the determinant here is negative 26. Now to finish out your homework, I'd like you to try to find the determinant of these two 3x3 matrices. Remember, your formulas are right here, and you can go back and listen to those two examples from before. Good luck!